Okay, Assalamualaikum. Turn to page 131 in your textbook, Module 8, Extremum of Function. So in today's lesson, we will explore another application of partial derivatives. Right, so refer to figure 1. The graph consists of high and low point. So among the higher and lower points, is it possible to have the highest and lowest point among all function? The extremum of function is to classify the nature of critical points of a function f of x, y by using second partial derivative test theorem. Discriminant equals to fxx times fyy minus fxy square. First, if d greater than 0, fxx greater than 0, therefore relative minimum. Second one, if d greater than 0, fxx less than 0, relative maximum. Number 3, if d less than 0, saddle point. If d equals to 0, inconclusive. So step, first cari fx, fy, fxx, fxy, fyy. Then identify critical point. Let fx equals to 0 and fy equals to 0. Then we have two equations. Then solve for the equation to find critical point. Third one, compute the discriminant d. Then check d and fxx. Classify as minimum, maximum, saddle point or no conclusion. Example 1, number 1, tutorial 6. So given that fxy equals to x cubed over 3 minus 3x square plus 6x plus xy plus 1 over 2y square minus 6y. Find the critical points and determine the relative maximum, relative minimum or saddle points if any. So step 1, find the partial derivative. So f subscript x, 3x square over 3 minus 6x plus 6 plus y. So differentiate second time with respect to x, 2x minus 6. Differentiate respect to y equals to 1. So f subscript y, so this one plus 1 over 2 constant, differentiate y square to y minus 6. So this one simplify. So differentiate second time, y 1. So second step to find critical point. So let f subscript x equals to 0, f subscript y equals to 0. X square minus 6x plus 6 plus y equals to 0. X plus y minus 6 equals to 0. So this one is equation 1. This one is equation 2. From equation 2, we get x equals to 6 minus y. Then substitute into equation 1. 6 minus y square minus 6 minus y plus 6 plus y equals to 0. So this one you have to expand. 36 minus 12y plus y square. So minus 36 plus 6y plus 6 plus y equals to 0. So simplify. 36 minus 36. So minus 12y plus 6y equals to minus 6y plus y square plus 6 plus y. To simplify, we get minus 5y plus y square plus 6 equals to 0. So this one, rearrange. Y square minus 5y plus 6 equals to 0. So you factorize. So y minus 2, y minus 3. So you get y equals to 2, y equals to 3. Substitute into x. X equals to 6 minus 2, 4. 6 minus 3, 3. Therefore, critical points 4, 2 and 3, 3. Right, next step. So to calculate D. First, draw tables critical points. So 4, 2 and 3, 3. Second column is fxx, 2x minus 6. Next is fyy equals to 1. Then fxy equals to 1. The next column is D. Last column, conclusion. We substitute the values of x here. So x equals to 4. So 2 times 4 minus 6 equals to 2. 2 times 3, 6 minus 6, 0. So this one constant. Just write down the value constant. So remember D equals to fxx times fyy minus fxy square. 2 times 1 minus 1 square equals to 1. This one 0 times 1 0 minus 1 square, so minus 1. So conclusion, look at the value of D. So if D greater than 0, fxx greater than 0, therefore relative minimum. If D less than 0, saddle point. Let's try question number 3. Find all the extremum points of fxy equals to 2x square minus 4xy plus y power 4 plus 2 and determine the nature of the points. Follow the same step. Right. Fx equals to then step 2 to find critical point. Let fx equals to 0, fy equals to 0. For x minus 4y equals to 0. So this one x equals to y. Negative 4x plus 4y equals to 0. Then substitute x equals to y. Negative 4y plus 4y equals to 0. So this one factorize. 4y minus 1 plus y square equals to 0. So for y equals to 0, y equals to 0. And this one y square equals to 1, y equals to plus minus square root 1. Then substitute x. So when y equals to 0, x equals to 0. So here we have two values of y. So if y equals a positive 1, x equals to 1. If y equals to negative 1, so x equals to negative 1. Therefore, we have three critical points, which is 0, 0, 1, 1, and negative 1, negative 1. Right, step 3. So critical point 0, 0, 1, 1, negative 1, negative 1. So fxx equals to 4, fyy equals to 12y square, fxy equals to negative 4. Then next column is D, then conclusion. So this one constant, just write down 4. This one also negative 4. Here we substitute the value of y. So 0 equals to 0, 1 equals to 12. This one negative 1 square equals to 12. Then 4 times 0 minus negative 4 square, negative 16. So this one less than 0. Therefore, conclusion, saddle point. So fill out the rest. Question number 7. Given that fxy equals to 8x square y plus y square plus 4xy plus 2. So first step, find the partial derivatives. Step 2, let fx equals to 0, Fy equals to 0. So this one factorize for y. For x plus 1 equals to 0. So for y equals to 0, y equals to 0. For x equals to negative 1. So x equals to negative 1 over 4. But this one is not the critical point. So substitute 1 by 1 into equation 2. So first one, y equals to 0. So 8x squared plus 4x equals to 0. Here x equals to negative 1 over 4. Negative 1 over 4 square plus 2y plus 4 negative 1 over 4 equals to 0. So this one you factorize. Therefore, critical points equals to 0, 0, negative 1 over 2, 0, and negative 1 over 4, 1 over 4. Right, step 3, critical points. So we have 3 critical points, 0, negative half 0, and negative 1 over 4, 1 over 4. Fxx equals to 16y, Fyy equals to 2, Fxy equals to 16x plus 4. This column is D, last one is conclusion. This one y equals to 0, so fxx equals to 0. This one constant, so write down 2, 2, 2. This one x equals to 0, so 4. So 0 times 2 minus 4 square. So d equals to negative 16. So less than 0, saddle point. Alright, so you fill up the rest.